Team, I'm going to give my best shot to be able to give this information to you quick and easy to help you guys tackle 7.5, the assignment here for it. I wanted to first take a look at number one and remind you guys that when we look at a K value, that means at equilibrium, if the K value is smaller than 1, we're going to move towards the reactants. If it's 1 exactly, they're going to be equal. There's going to be an equal no movement towards reactants or products. If it is larger than 1, it's going to move towards the products. So let's look at our K value. I'm looking at this K value, and it's really small. So therefore, we are definitely going to move towards, okay, and let's see if I can draw this correctly. Yeah, we're going to be moving towards the reactants. Okay, so when I look at my answers, I'm going to be looking for concentrations that are either X or Y rather than that are bigger. So let's look at A. A is Z is greater than X. That's not possible based on what we just established. So that can't be it. Y is greater than Q. That's possible. Okay, so I'm just going to put a little dot there, being like, yeah, that could be. Z is greater than Q. No, sorry. Z is equal to Q. Nope. Equal. Nope, that can't be at all. Okay. We can't assume any of that. The only one that's possible is B. All right, let's head on to number two. Number two. Now, what I've done, and this is a cheat that I use when I'm making my ICE tables, because for some reason when I write out all of these, the formulas, the letters, it's easy for me to get confused. So at the beginning, I just say, okay, I got A, B, C. And then I just do A, B, C really quickly, and I keep my coefficients to remind myself when I'm doing the ICE work to keep that into my calculations. So let me see if I can jump back over to text, and let's just get right into it. This question says that I need to start with 0.8 moles. Ooh, I want to use a different color so that you guys can see that a little bit better. Okay, so my first one is going to be 0.8 moles in 1 liter, so that's going to be 8.8 molar. Okay, it's kind of nice that they gave it to us in a 1 liter container. Okay, so then when I get to B, that means B, I don't have anything to start with for B. Same thing with C. Okay, but now when equilibrium is reached, I'm only going to have, 54% of the original will have decomposed, or I will have lost 54%. Okay, and so, and what we've practiced in the past when we get to the change is we say, okay, so we lost some stuff, okay, and then we gained some stuff, okay, and then for C, which is kind of unique, that I haven't really talked to you guys too much about, that coefficient goes here as well. It applies to that X value, okay? And so I'm like, all right, and then whatever these are, they will determine what I have at equilibrium. But what's unique here with this problem is they've told me what my X value is. And how I can get that X value, okay, is I can just calculate it really quick. So 0.8, okay, times 54%. 54% as a decimal is 0.545, okay, 54.5%. There it is. And so then I have X is equal to 0.436. Okay, I did this a little bit earlier this evening, so I'm going to double check my work times. 0.545. I've got, yep, there we go. Our X value is 0.436. And oh my goodness, my little hairy baby here came to join Dad with his chemistry, and she's totally killing me. Oh, she's going for the microphone. You little stinker, I love you. All right. You missed.
Can she be in here with you?
Yeah, you want to hang out with Daddy while Daddy records some boring chemistry? Okay.
I'll leave the doors open so she can come back.
Okay.
Sorry, guys.
Love you too.
Sorry, baby, Mr. Daddy.
Hairy baby. All right. Okay, so now if we take that X value and we apply it, okay, what that'll look like is 0.436, okay, wherever there was an X value, 0.436. And this one's going to be 1/2. So it's going to be plus 0.5 times 0.436. Okay, all right. And then we come down here. So I'm going to bring those closer so that you guys can see it. All right. And then once I calculate those out, I got 0.8 minus 0.436. Okay, and I get 0.0364 for my A value. For my B value, I get no, but John, getting bombarded by my sweethearts here.
I'm sorry, guys.
It's okay. Come bother us anytime. That was adorable. All right. The B value. That one's really nice and easy because it's just 0.436 if you guys are following along. And then the C value, because it's going to be a half, okay, half times whatever our X value was. This one is going to be 0.436 divided by 2, which is 0.218. Okay, so there we go. We've got we've done our ICE table. Now we can use this equilibrium value to calculate K, which is what we're being asked to find. So K is going to be equal to, and we have on the top is going to be our products, which is 0.436 on the top times 0.218, okay? And that 218 actually is going to be a square root, so I'm going to go to the half power for that. Okay, and all of this needs to be underlined, control, oh boy. And that's an interesting thing right there. And that's all going to be divided by, this is annoying. I'm going to have to use this notation to show you guys. So all that is going to be divided by, and I'll write it on the next line down so that you guys can see that, so that it's a little bit more clear. Okay. Products divided by reactants, 0.364. Whew. Okay. So that is how I'm going to get my K value. And if you type all of that into a calculator, okay, and I did this earlier, I'll do it again, 0.436, okay, times the square root of 0.218, okay, divided by 0.364, my total comes out to, K is equal to 0.559, okay, and again, 0.218 to the half power, and I got that half power from this coefficient here, is actually the square root of 0.218. I don't have an easy way to type that in here to show you guys, but just know that means take the square root of 0.218 there. But that's how I got there. Number 2 was kind of tricky. I actually had to make a few mistakes, and then come back to it. I tried to keep my bad words to a minimum, though. Here we go. Number 3. All right, number 3. They want us to start when we've got pressures, gas, 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 so that we can do our K calculations. This is great news. My initial is 1 atm there for A and for B, and then I have 0 for C. Now I'm going to go down and say, how are we going to change it? Well, we're going to change it. We're going to lose X, okay? We're going to lose X here, and then we're going to gain X. Okay, finally, we're going to go to 1 minus X, okay? It's going to be 1 minus X. And then it's going to be here, it's going to be 2X. And again, I should have put this right here. because it has a coefficient, that 2 actually should be added right there. And that's a mistake that I made earlier in the evening that, like I said, I might have spent a few bad words on that one. Okay, now that I've done my ice table, we're like, okay, what the F, okay? I don't know what to do. I can't really do anything with it. And the reason why is because they gave us our K value. Okay, that K value, I'm going to switch colors here, and I'm even gonna circle it. This K value is what we need to set our work down here equal to, and then we can solve for what we're being asked to find. And I'll switch colors. I'll switch over to green just to kind of highlight. They're asking us to find HI. Okay, so this is what they're asking us to find. And if I come down to equilibrium, that means that they're asking me to find it. They're find this one right there. That's what I'm being asked to find. Okay, so, and what I need to do at this point, okay, is I need to go to red. Actually, I can type in red for this one. All right, let's switch back over to that because my writing on this one's not great. So 90.6 is my K value. So it's K is equal to products over reactants. And my products are 2x, okay? And because it's 2x, remember, that's going to be a squared value. That's squared, okay? Over, okay? And, oh man, like I said, I don't really have a good way to show this, okay? Divided by, and so I'll put it down here on the bottom so that you guys can see that. There should be a line there. Oh, I could just draw a freaking line. Why don't I just draw one for you to make that a little clearer? Let's draw a line right. Oh, come on, baby. Let's draw a line right there. Come on. Draw a line right there. Beauty. I'm feeling better about that. It's hard enough if I don't make it as clear as I can. So, all right. So we've got 2x, and then on the bottom, we have, for reactants, we have 1 minus x, okay? And then we have times 1 minus x, okay? And that's the same. I'm just going to rewrite that. That's the same as saying that squared. So just like we had happen last week, this is where scary things happen, my dudes. I'm going to switch to the color green just to emphasize this next part. Okay, let's, yeah, we're going to switch back to being able to draw with color. Yep, there we go. Because I have things that are squared on the top and on the bottom, I can do the square root of everything on both sides to try to solve for x. And once I do the square root of everything on both sides, now things get a little bit different. Now I'm down to 9.52 is equal to, okay, and then I've got 2x. Let me draw that line again. Drawing that line's a little tricky. Okay, 2x over, okay, and then I'll put that down right here, 2x over 1 minus x, okay? So now if I do some algebra, and I'm going to expect that you guys can do this algebra. If you can't, please come see me. We can talk about it. We can work it out together, okay? If you can't solve for x here, come talk to me and we can do that. Okay, I'm not going to do all those steps here. It's kind of tough to do on a computer. But our x value should come out to 0.0826. And this is where I made a mistake last year, and it killed me because I got all the way here, typed in the answer, and I was like, how is it wrong? What are we trying to find? Are we trying to find x? Look back here what I circled earlier. No, we're trying to find 2x. And so our value for HI, which is equal to 2x, is actually, that concentration is going to be 0.826 times 2, which is 1.65, okay? And that's 1.65 ATM. So there you go, guys. You've got it. That's how we find number 3. Number 3 also. Number 2 and 3, man, they gave me some trouble. Number 4 wasn't as bad, and I'm kind of excited to end on one that's a little bit easier. We're only 15 minutes into this tutorial. Maybe you're watching me on 2 speed to try to get through this, but let's see where we're at here. I've got my ice table set up, and I need to, let me change colors so that it's a little bit of juxtaposition for you. Okay, so I've got 1.5 right there. I'm not showing all my significant figures, and I hope you guys will forgive me. I'm taking a little shortcut. Technically, this should be, if I'm being exact, 1.50. Man, what am I doing using letters there? It's getting wild. Okay, and then the change, we lose x, okay? And if we go all the way over, okay, we're going to gain some x plus x. No coefficients on these, which is always a good thing to double check right here, okay? And we're going to gain an x again, and then we come down, and that final is going to be 1.50 minus x, okay? And I'm just going to have x here for B, and then for C, I'm just going to have x. Now, let's see here if I can then do something with that. They have told me that the combination, due to Dalton's law, of all of my pressures at equilibrium, they all add up to 1.90. So I know that 1.90 is equal to the total, which is all of my gases working together at equilibrium. Okay, so that's going to be both the products and the reactants, because we're at equilibrium. We're figured it out. We've got it. It's happening. Okay, plus x. Okay, now I'm going to expect that you can do some fancy algebra here, okay, and solve and get that x is equal to 0.4. Okay, so we've now established, and this is where a lot of people are like, oh, I got the answer, 0.4. No, dump that 0.4 back in here to figure out what each one of these concentrations are. And I'm going to switch to the color green, want to dump that those back in here. 0.5 minus 0.4 is 1.1 for this concentration. This concentration is going to be 0.4, and then this concentration is also going to be 0.4. Okay, so I've got all of my concentrations there. Which of the following is true about the equilibrium constant of Kp for the reaction? So now I just use those to calculate K. And I'm gonna, I don't know if I've used the color blue in this program yet. Why not? Let's calculate K over here. K is equal to products, which is going to be 0.4. And I'm just going to take a shortcut. Actually, I'll just show you all my work. 0.4 times 0.4, okay? And that's all going to be divided by, okay? Divided by, well, hell. On a whiteboard, this is a lot easier. We got this. 0.4 times 0.4, those are my products right there, divided by my reactants, which is 1.1. 1.1. All right, I got it. So we got K, and I type that in, and the value that I get, team, my K value that I calculated is K is equal to 0.145. Now, which of these matches K is equal to 0.145? The value that I got for this one, team, was B. Okay, I got value B on this one right here, okay? Because it's between 0 and 1. But thanks so much, team. I apologize this video is so long, but these ones, man, they're tricky. I wish you success, and I hope this video helped you guys out a little bit.